it's growing by leaps and bounds.
Welcome to the Software Toolworks World Atlas for Multimedia Windows.
I didn't even know this job existed.
Well, welcome on board anyway, guys. Nice to see you. I'll see you around the ship.
With a little cheek here and a little lips.
You think I struck gold?
Our reward we get down here is when people say you have the best fish.
Hello, I'm Ron Barber. Never before in the history of us have things been changing so fast and with such dramatic results. Things are just not what they seem for very long. What's in one day is out or outmoded the next. What's hot suddenly is not. Where we are 1 minute can be where we were in another moment. Blink your eye and whole new worlds open up. Or you can blink twice and go way, way back to old worlds. This is no game. It's virtual reality, and it is virtually now. We can enter an entire universe and rearrange either the results of battle or the design of a kitchen. We have unmasked the Lone Ranger and have found that Superman is not dead, but alive and everywhere around us, and through interactive media will ultimately be all of us, able to leap tall buildings at a single bound, faster than a speeding bullet, more powerful than a locomotive. That is what the world of interactive multimedia promises you and me, and career opportunities you've never read about in any want-ad.
Echo Station 5-7, we're on our way. Dak!
What we imagined just yesterday has now become reality today. The creative minds at Software Toolworks in Northern California have been forging dreams into multimedia entertainment and edutainment that seem to explode off the computer screen.
The neat thing about computer software is you can create just about anything you can imagine. The only limitation really is how fast a computer you need to realize your dreams. If you put enough hardware in the problem, I mean, as these new virtual reality games are showing, you can do just about anything. You can create an entire world out of software, out of nothing.
I've come to tell you about a new wave of software. It's respectable, it's educational, it's entertaining. Check it out. Help guide Luigi in his search for Mario by traveling to dozens of cities, recover the goods, and foil Bowser's evil plot. It's more than just a game.
Talk about artificial intelligence. When you come to Mario and Luigi for help, you know you're in serious trouble, or into serious dollars.
Combined with the best-selling video game character of all time, it's huge.
Luigi, what do you say we give a Bowser the old Brooklyn 1-2?
Mario Brothers and interactive video games like them are now a $500 billion business. Bigger than the TV networks, bigger than the movies, and getting bigger and better all the time.
I even forget what was down there before. It was just plain, wasn't it? But now it looks like it's underground. Let's see.
What started out as a game is now an industry. Multimedia is expected to be the fastest growing area of technology over the next 10 years. And it is Mario and Luigi, along with Bowser and the evil Koopas, who are bringing multimedia edutainment into every home in America.
Yes, hi. This is Jay Balakrishnan at the Software Toolworks. Hi, how you doing? I'm returning a call that you...
Jay Balakrishnan is a producer at Software Toolworks, home of Mario Brothers Edutainment. It is Jay's job to get Mario and Luigi onto a CD disc and out into the marketplace.
What a multimedia producer is essentially is a jack of all trades. Many of the games that you have seen produced, like Mario Brothers and whatnot, obviously there are a great number of people that it takes to produce such a product. And what a producer does is makes certain that it is coordinated with art people. There's also sound, there's also various packaging issues, advertising, public relations, and many other facets of creating a product, and the producer is the person in charge of making that happen. It's not unlike a movie producer.
Star Wars chess. Long ago, in a galaxy far, far away, a magnificent story of courage, adventure, and animation was created by George Lucas.
One of the things that excites me about being a producer is that I get to meet people frequently on the phone, but also in person. Every single day there are new opportunities, new programs are submitted to us, and so on. And in licensing, you meet these people and you work out an agreement financially, and then you also get involved with lawyers, and they have certain contribution to make as far as the legal wording goes, but essentially the business deals, how much is it, how much is paid in advance, what period of time, all the deal points are made by the producer and agreed upon by the other party as well. So that's a very important role of a producer, is negotiating and interacting with people. Another area that we do is essentially packaging. A producer is intimately involved with packaging. And what I mean by that is we first analyze competition and the marketplace. Let's say it's a Mario educational program. Well, we have to identify who the target audience is, see who they are, what appeals to them, and what kind of programs they like. And then we put that knowledge into the product and also into the packaging to appeal. You would not use the same kind of packaging as a toy for, say, a 3-year-old as you would for an adult. And therefore, it's very critical. Most of the time, most people do not know about the product. They have not been exposed to our advertising or our press. That's the reality. So the biggest amount of advertising that is done is the package itself. A person opens it up, and you have to sell the product in the packaging.
I think this will really stand out on the shelves.
Yeah.
What do you think, Jay?
I like it. This is a new look that we have for World Atlas. It's one of our products that we've had for a number of years, and we have to continue to maintain the old name and recognition, and yet continue to
give it a fresh new
look, something new.
We've been thinking about putting foil along
Gold
here.
foil?
Yeah. What do you think?
I think that's very interesting.
Don't just read about the world, experience it.
Julie Lippold began her career writing science fiction. Now, she finds herself designing artwork for the equally strange world of Mario and Luigi.
I had a degree in fiction writing and just happened to get into advertising by accident, liked it, and stayed.
What was the accident?
I needed money. I think the artistic aspects of it appealed to me. And once I got into the field and realized how quickly things changed and how much you had to keep abreast of those changes, I decided that I enjoyed it quite a bit and have pursued it ever since. It's all going to be on computer. Soon, none of this will exist. This will be a thing of the past, and everything that we do will be done just like this on computer, and we'll go straight to film, which now is about a 4-step process. I think any young production artist who is interested in getting into the field must learn some of the more popular applications on Macintosh. And I think that once those applications are in hand, he or she can take a variety of avenues within our industry and can basically go anywhere. They can do computer illustration, they can do basically computer production art, they can do computer animation, which is a new field that's opening up. There are a variety of fascinating new things that are changing very quickly right now.
Check it out, okay?
Jeff?
Yes.
Hi.
Hi.
I believe we've got some new art in.
Yes. One of the many talented people from around the globe who've come to San Francisco and the world of interactive multimedia is art director Vicki Sidley. For this British artist, the world of interactive computer learning offers a new canvas on which to paint electronic images.
Yeah, let's, well, I see that this is different here, but we can still have some battle taking place here for Joan of Arc. The nice thing about multimedia is that it opens up the whole scope of the kind of graphic images you can use on the screen, and that incorporates not only still images, but animation, digital video, high-end 3D animation. A computer graphic artist still needs to be able to draw and have a good sense of color, design, and form. And when I have people come into this office to be interviewed, that's the kind of thing I look for. I look to see that they have the basis of drawing skills, a good sense of color and design. Another thing I look for is their knowledge of computers in general. If a person knows the operating system of a computer, for instance, how to get around DOS, that is very helpful. So, and that would mean we wouldn't have to train them in that capacity. I think that it could be a little fast.
Okay.
Maybe we could just slow it down slightly by 1 frame a second.
Let's do that. Make it 7?
Yeah.
Okay.
That's a little better.
What I'm doing here is I'm actually having to draw each little frame of Mario when he's doing the hand movements.
Animator Don Guerra started out as a business major, but when he saw an ad in the paper for a job as a computer animator, he penciled himself into a new industry and a new career as well.
What I'm working on here is Mario Early Learning. It's a game for little kids between the ages of 3 and 5. And what they're doing is they're going to learn how to do the itsy bitsy spider as he goes up the water spout. I'm using D-Paint animation, which allows me to go frame by frame and basically create a little cartoon of Mario doing the hand movements and the spider himself, acting out the song The Itsy Bitsy Spider, and then there's the sun.
Neat feature that I wanted to show, and I forgot how to get it to work. So I'm calling our tech support department, who is going to let me know how this works.
Good afternoon, this is technical support. How can I help you?
It is a good thing for Jay that Milt Hodges is on the line. Milt got out of the Navy and into computers by way of the shipping department.
It shouldn't be a problem. Yeah, it shouldn't be a problem at all.
Put that in there.
You have to be able to to relax all the time and just take every call with an upbeat tone. And if you come into a tough problem, not be discouraged, because you can always tell the customer, I'm not sure what that answer is, but I can find out for you. Put them on hold and go find out the answer instead of, you have to be able to really maintain the cool. You don't have to go to a full-time college. You could go to a community college, take up courses for Windows. One course I strongly recommend is Intro to Computers, which most secondary schools offer as well. Like I say, I came in here not knowing anything about computers, and I've been doing really well.
Cool.
You would think Robin Rittenhouse would practice the piano on her own time, but in this case, Robin's playing is also working as a quality assurance technician, the person who tests the interactive programs. This computer software teaches piano, or at least it's supposed to. The challenge is to find the bugs in the programs before the customer does.
If I click on a different button, it should go to where it's supposed to go. If I click the main screen button, it should take me back to the main screen. If I were to click that button and it didn't go anywhere or it went somewhere else, that would be a bug. That would be a problem. It can get pretty stressed when this thing has to ship, get it done. I've worked 18-hour days for 3 weeks on occasion, which is very tiring.
Work, work, work. Work.
Oops, doesn't mean I can play them right.
Robin may have her work cut out for her. Multimedia products and services already account for more than $2 billion in sales a year. In 2 years, that figure is expected to
3DO
double.
Sega CD.
With new computers bringing movies, photos, animation, and text into the home, multimedia promises a revolution in education and entertainment.
And with World Atlas 4 on CD-ROM, you'll see over 1,000 pictures of worldwide locations and extensive motion video of the world's greatest cities. It's all at your fingertips. Full motion video, sound, text, and photos for a view of the last 100 years.
Multimedia is how the next generation of students are going to learn. What we have done is taken the license of Mario and created games that are actually a learning experience. It's what we call stealth learning. And that is the thing that excites me most of all. You can have fun playing with Mario, but younger kids and older kids will be learning things without actually being, you're not really learning it per se. It is just entering you, as I say, stealth learning. And that's the most exciting thing of all, because as a producer, you are able to literally affect the outcome and influence education of children in the future.
I'll see you there.
Multimedia is pictures, video, sound, animations, and text. It's all the media elements that we think about when we think about TV or records or print media.
Mike Duffy received a degree from Harvard in electrical engineering. That's because there were no courses in computers back then. Now, Mike develops and programs a whole new world of interactive experiences he once only dreamed of.
In this case, we have a virtual zoo with recreations of Earth's habitats, like the tropical rainforest. And you can hear in the background a little here, we actually have the sound of what it would like to be standing in a tropical rainforest in New Guinea. This is what programming is all about. Essentially, it's sitting at a computer terminal and typing in instructions to the computer, and it's not very exciting to watch. What is exciting about it is what happens when you're done writing the instructions and you actually get to run them and see them create something that maybe you've never seen before. A picture on a screen, a sound coming out, any number of things. That, like I said earlier, the neat thing about computer software is you can create just about anything you can imagine. There's nothing like writing some code, putting it together, running it for the very first time and seeing it do what you imagined in your mind it would do. There's nothing, and it's like hitting a home run. There's nothing to compare with that experience.
The experiences you are creating for yourselves today could be the first steps of an exciting journey into the 21st century. When we say artificial intelligence, some of us may get a queasy feeling that someone or something is watching us. But artificial intelligence, coupled with human intelligence, is creating the jobs of the future.
What system is this on? A VM system?
Take Patty Connor. As a customer service representative at IBM, she would tell you herself, but she is too busy answering questions about disk drives, passcodes, and the way to San Jose.
Okay, so passwords can be reset by managers under EEPW. Do you know if your manager is in the office?
Now, Patty doesn't know everything. It just seems that way. That's because she has a team of computer specialists behind her. giving her the multimedia software power to answer any question put to her by IBM customers.
Without that information or the system to deliver it quickly, we won't be able to provide the services in our service-based society of the 2000s. And that technology, I think, is going to be one of the keys.
Technical analyst Edward Youngblood, systems analyst Alice Patrick, and knowledge engineer and project leader Rufus White created the program that gives Patty her superpowers. And the key to the program is interactive media. Interactive multimedia promises to revolutionize the way we work, learn, and communicate. By combining text, graphics, sound, animation, and video, interactive multimedia lets people interact with information. Interactive media will let us communicate with our co-workers through voice and video.
That's where the technology gives us a lot of power, right, to be able to allow people to use the complex environment that we're building. And as we get further into the future, our life's going to be more complex.
That's right.
And we're going to need more complex fixes in a quicker way, more complex information, and more available to us.
Are all these people in the same building?
So we're going to human-based experts, machine-based experts, and the distribution of that information on a real-time basis. And that's what one of the keys are.
We think that this is going to grow not just with the help desk, or not just with the help desk in this environment, but also with like 1-800 numbers where people are calling to get information about many different things, not just computer systems. Call and get information about TV repair, call and get information about personnel, call and get information about a myriad of things. But we do see a constant growth.
What we really wanted to do here with the K-Space was to get information from the people who really do answer the phones, the people who know the problems and the solutions, and put that into a K-Space so that new people coming in will be able to use it and get up to speed very quickly.
In school, interactive courses will allow students to explore a new techno-arcade of video and virtual reality. The boundaries of this digital revolution are mind-boggling.
Can anyone think of another way to say that? Cereal? Cereal. I like that one. Good. Try that.
This new digital revolution is being led by people like engineering student Terrell Prudet. He is part of Rufus White's team of computer programmers. Terrell sees a world where his work on artificial intelligence may lead to medical school and work on the human brain.
What an expert system does is it basically takes the knowledge that a doctor or a registered nurse might have due to the experience and stores it in the computer. So when the new doctors or whatever, when the new personnel come in, they can access this knowledge long after this doctor or registered nurse is gone. So that would help in diagnoses and, for that matter, even in laser operations during surgery.
One of the things that this brings out is that planning and design are very, very important if you're going to do quality work. And Terrell's done an excellent job in this design.
It takes a lot of brain power at IBM to design and program the interactive media of the future. One of those Rufus depends on every day is Zita Peterson of Engineering Services. Zita keeps the office together so that Rufus and the team stay together. She knows the game plan of the future can only come true if you know what filing cabinet you left it in.
Rufus is a very busy man establishing the expert system technology implementation, and I help him run the office when he's off to meetings. And we always joke here in the office, I keep him out of trouble. I make sure his reports get on time, and I give the information that's needed to his superior manager, his upper level management. This job is a high focus position where you need to be able to interact very well with other department members. You need to have a good organizational background, knowing how to work with files, word processing, so you can do your communication and pull together all the information into a report and then build it into the system. It's a team partnership. I support Rufus and he supports me, and we have a real good time at it.
it, trying to work with people outside IBM and inside IBM to do their jobs better, quicker, faster, more efficiently.
Another trailblazer in the world of artificial intelligence is systems analyst Alice Patrick. When she came to IBM, there were no college courses in computers, so she had to learn on the job. Now, she is a leader in the field of artificial intelligence.
What we do is build up cases which show problems that have occurred, questions that people ask to determine exactly what the problem is, and then the appropriate action for that particular problem. When I started with IBM, computer science was not a well-known area, and IBM trained me. And IBM still does a lot of that, training its own people. But it's really helpful to get into a company like IBM to have as much computer knowledge as you can about both PCs and maybe even mainframes.
A lot has changed since Alice joined the computer revolution. This is a world of training opportunities waiting for you in school and at work.
We have a couple robots.
Beth Baker is a computer graphics trainer who is inspiring a new generation of designers with a new generation of computer design tools.
And we can actually simulate the movement of all these parts as they come down the screen. Part of the mission here we have is to train our engineers and designers on how to use computer graphic tools to design the products and tools that support the building of our products here at IBM. In that area, one of the tools that you see behind me is called CATIA, and we have engineers and designers that come into this classroom and learn how to use these tools to go back to their area and design the products that they develop. The whole world of design and computer graphics is opening up with so much potential that there's still new worlds to explore, and the imagination of the user is the real key to make all this fit together, that you can make anything happen if you've determined to do it, using what is available today and then expanding on that and developing, whether it's programming or engineering. The future is endless in what you can do with computer graphics.
Making all the parts fit together in a computer program or on an assembly line, these young women, Cindy Elgie and Shasta Suazo, are doing it all through 3D computer design, boldly going where no man or woman has ever gone before.
When I design a part, I can see right away if it's going to work on the line or not and what kind of problems we'll run into. Because you can do 3D demonstrations of interference, I know right away if I have to change a design or if we have to come up with some better idea because we can't change what we have. In engineering, we see it especially as mechanical. There's not a lot of females in our class. Out of the freshman class of like 60, there's maybe 5 females. But it's not that no one teases us, no one says, oh, you're a girl, you can't do it. We're treated just the same.
As long as you have faith in yourself and you can show that you have the faith and that you believe that you can do it yourself, no one else is going to say that you can't.
If you have the determination and interest, there's a lot of things you can learn that helps you out in your future. So don't look at strictly as you've got a job to do for IBM here. You can still take advantage of the opportunity to learn other things above and beyond your job.
Some of the careers of the 21st century involve programming, assembly, manufacturing, logic and layout design, testing and validation. For project manager Rufus White, the road to interactive media is a part of a bigger journey of self-discovery.
Technology really is another word for science, and it's really a word for what's called new science. So what we're able to do is to take computers from their basic use, add new science to it, and take them to today's use. And getting into that field, the field of computer technology, was one of the key decision points in my professional career. Knowledge-based systems is when you allow computers to be used to collect the knowledge of various experts and make that available to those who need it. That could be in the work process, it could be as a training vehicle, or it could be where people have now taught the computer to help them do work where they can be present or not. So professional engineers, whether you're a knowledge engineer, electrical engineer, are really there to solve problems and to help people. So the real key is to take the science and do something that's useful with it,
and have fun while you're doing it. That way, then you know you're doing your best, and you've made a contribution to society as well as to your technology.
The new information technology is the driving force in the creation of new jobs for the next century. Over the past decade, service companies have invested more than $800 billion in information technology and hardware. This headlong rush into computer-based intelligence is the wave of the future, and companies will need more and more info surfers to ride that wave of digital data.
Anytime you use a credit card, that information is stored on a database. This is DASD. This is where the database is actually stored. All the information resides on here. This business is continually growing and will not ever stop to grow. The reason for that is the amount of information stored is dependent on the number of people in the world. So long as people keep coming in the world, our business will never stop.
Besides database developers, interactive information systems will need process engineers to make sure the system works. That's where Carlos Fontano comes in.
As hardware does get more complex, we need programmers to write the software that retrieves the data from these machines, that stores the data from these machines, and this is the wave of the future, the information processing. As the software gets more complex, we need people like myself to test it, to develop test cases to run on these machines, and also to solve new problems that occur during the test cycle, during the development cycle. Software is going to be the future. This is a very large industry right now. It is going to be getting larger, and people like myself will be in demand.
We're working on bringing the time down as far as how much time we're using on the phone to correct a problem. That time has decreased.
And speaking of demand, Rufus's team is in the final stages of creating a software program for IBM customer service rep Patty Connor.
Basically completed the first wave of the project.
With information technician Edward Youngblood, Rufus and Alice are in the home stretch.
It turns out that on every project, our organization are providing the services to our customer, who is, Ed represents our customer. They're the people who actually use the applications that we build. What we try to do is to make sure that we can, after it's deployed, after the programs go into operation, we measure them to see if we actually achieve the goals that we were trying to with writing the programs and the case bases.
I don't need to be an expert in all systems. I don't have to be a programmer. I don't have to be a third-level support person. I can enter a simple message up at the top of the screen with some basic troubleshooting skills, which are people skills that I bring with me, and the system will answer my questions and give an answer that I can give to my customers or clients that won't take as long as it would just relying upon my training and my knowledge. So I can come into any situation and be an expert with this system, even though I don't have that specific training. So that's what makes it easier.
Patty Connor's interaction with customers is made easier through the team efforts of Rufus White, Alice Patrick, Ed Youngblood, and the rest of the IBM team, who are working together today to solve the problems of tomorrow.
Do your best. Think, imagine, be creative. And if you do your best, what you'll find out is that your best gets better.
We have all seen unreal images look real on the movie screen. This magic requires not only the imagination of the artist, but also the powerful technology of computer software design. That's where Sharon Fischler comes in. She's a graphics engineer who comes up with the programming and the new machines to make complicated scenes like this.
Well, all the problems that I deal with tend to be revolving around trying to get things in reality to look real on the computer. And the problems are so many and so great, it's hard to figure out where to begin. I mean, the whole process of even just taking photographs and having them look reasonable in here is very hard.
Yeah, that's nice. Electronic information is coming in all shapes and sizes. That's because supercomputers are able to transform tons of data into hefty visual images that are very hard to ignore.
Welcome to Jurassic Park.
What I do every day is I play all day, and that's what my goal would be for the perfect job, is that you get to call what you do fun and play. But I do a fair amount of programming. I do a fair amount of thinking about hard problems, because the one thing that makes my job really neat is the feeling that I solve problems and help people do things that they couldn't do before, and that we're doing things here that no one else can do. And that means, yeah, you have a lot to think about and a lot of problems to solve. And I get to play with a lot of people's applications and help people with real problems use stuff that I build. And that's a really neat feeling, to help those people and know that I improved what they were doing.
Right now we're coming up on Normandy. We're going to be making a left here.
Leo Estrada of Rebuild LA and management consultant Keith Alexander are taking a tour through the riot areas of Los Angeles. They've already been there in person. This is a tour through an interactive computer simulation created at UCLA.
It allows you to think of the area as a whole rather than building by building.
UCLA researchers say this kind of computer simulation, as opposed to traditional reports and blueprints, can bring people from the community into the urban planning process.
A visualization, I think, does in fact work. I mean, the abilities to visualize what the changes might be like, it's got to be very powerful.
Look at it over here.
UCLA's Graduate School of Architecture and Urban Planning is using the world's fastest computer graphics to simulate South Central LA. Silicon Graphics provided its new reality engine to the project as the only computer system that's able to create interactive, real-time simulations of such complex scenes.
We're putting the actual plans into a medium which everyone can understand. One of the main reasons that the community feels that they're not being a part of the planning process is, in fact, because a lot does go on behind closed doors. And I think that we can use this technology in many ways to solve that problem.
We wanted to create a better understanding between the technicians, the engineers, and the planners with those people that live in these types of neighborhoods. The Silicon Graphics computers will bring to the process a very basic understanding of what can be done versus what was there before.
This is also exactly what was done for the Rebuild LA effort. So I'm using the mouse to drive through the scene. So I just push a button on the mouse and I start to change my position. I can go anywhere. That's the fun about simulation. You're God, you're in control. But when people are working on things, they're also just controlling what the scene looks like. If I show you, I can just turn off texture in the scene. This is just a graphical control panel to help make control of what we're looking at further interactive.
Sharon interacts with the images on her computer by guiding herself through a virtual reality she created on her computer. But creating a career for herself wasn't nearly as fast.
When I was in high school, I had no idea what I wanted to do, and I thought that maybe I wanted to be a lawyer or a judge, which was pretty different from computer science. And so I got into this through a pretty indirect route, and I just took a lot of mathematics because I found it somewhat fun, but certainly people had advised me to do that. And when I got to a certain point, I started taking a lot of computer science courses, and I just suddenly found myself enjoying what I was doing there so much more than when I was doing in other areas. And I just got into it slowly, and then once you find a niche for yourself, you know it, and that's a great feeling. But I would say that it is becoming a central thing to so many disciplines. And I would say I know because I'm helping people in so many disciplines solve the problems with graphics, be it trying to build a model of a plane or a car, or build a training simulator for people learning how to drive or fly planes, or chips or to build buildings and architectural walkthroughs. And just every discipline I can think of, we're helping someone solve some problem with computer graphics.
The bobsled run at Albertville, France. Not the real thing, of course, but a simulation, a computerized match of the Albertville track that can provide hundreds of vital practice runs for bobsled driver Brian Richardson and his teammates on the U.S. team.
What makes it feel realistic? It's hard to say, but I just look at the video and you just sink right in and you get the feeling that you're there.
The simulation, a form of virtual reality created at the University of California at Davis, is being operated and enhanced here at Silicon Graphics.
I would like to provide Brian and his teammates that just little bit of extra edge that puts them on the podium.
A victory of much greater proportions, Operation Desert Storm, was secured in part by the overwhelming superiority of U.S. tank crews, whose training, it turns out, included battle practice in virtual reality.
The future of manufacturing in this country may just be decided in plants like this, and by people like manufacturing engineer Greg Podshadley.
One of the jobs that I have is to make sure that the products get into manufacturing as quickly as possible. 3 weeks ago, we were building this computer that you see here in the blue box at a rate of about 20 a day. Today, we build at over 300 a day. This is considered an entry-level position as an assembly position where they're learning to put the machines together, learning to understand what parts of the machines, hard disk drives, processor modules, graphics boards, and the mechanical assemblies that are necessary. And this is where you learn just a lot of the mechanical aspects. The kind of jobs that we have available here are assembler jobs, where you're doing basic level assembly, tester jobs, where you're actually using the computer to test the computers that are being manufactured and make sure they're working. We have junior technician jobs, where you're actually taking the computers apart and trying to get them working again by replacing major components like printed circuit boards or disk drives. The fourth level job is a reject analysis technician, where you're actually taking those printed circuit boards or disk drives and taking them apart to the component level and trying to understand how they're working and what's broken, and replacing actual components like resistors, integrated circuits, gate arrays, those kind of things. And the fifth level job is a manufacturing engineer, where you're actually responsible for a piece of the process here. You're responsible for a product and a piece of the process and how things are being tested, creating things on your own, and making sure that the product that's going through your process is the very best it can be. There are a lot of things that we're doing here in the computer industry to try to make manufacturing much more efficient than it ever has been before. And how do we do that? We do that by really emphasizing quality. We do that by listening to the assemblers, the testers, the technicians, the manufacturing engineers, and getting their best ideas on how to make things faster and less expensive. And we do all that kind of thing to try to keep the jobs here. All of those things require a lot of education in some cases and very little education in others.
Right now what I'm doing is I'm powering up the unit and I'm checking the graphics, make sure all the demos look really nice, there's no defects before it actually goes to the customer.
If the technicians on the manufacturing floor find too many glitches, they may want to talk to this man.
Hi, my name's Dan Freitas. I'm a chip design engineer at Silicon Graphics. I work on computer design of high-density computer chips. The thing we make here is the actual silicon chips that are used as the core of the systems that Silicon Graphics produces. The chip itself is used in a board level design plugged into here. This board is placed into the chassis, which actually becomes the system. Our job is to design the piece of silicon that you see here. The piece of silicon is actually something that has on it 2 to 3 million transistors in this generation. In newer generation technologies, this will be anywhere from 5 to 7 million transistors. It takes about 2 or 3 years in total development to design one of these chips. The team size is about 40 to 60 people, so it's quite an enormous project to do one of these. My function here within the team is to do some of the design of the circuits themselves, is to look at what the instruction set requirements are, look at what the technical requirements are, and translate that through schematics, through pieces of layout that represent the physical implementation of this design into the system. These get integrated with all of the other designers' pieces and become the chip eventually. In the old days, Logix, every gate, that AND gate I talked to you about, was one gate. That might have been one of these chips. So this was an AND and an OR, and different logic decisions were made, and they were placed on each chip. As integration became more and more available, we took those gates and we packed maybe 5 of them on one chip, and then maybe 10, and then maybe 1,000, and now, right, we're packing 1,000,000 again. This one is again 2 million transistors on this, or maybe about 500,000 gates. And the more and the more and the more that you can pack on one chip, the smaller the systems can become. So in order to fit these things on your desktop or on the TV top or in your watch someday, or things you've heard about in these Newton personal communicators, all of that requires very, very small space. And this technology allows us to get to that space. So kind of the systems of yesterday are becoming the chips of today.
The traditional view of a supercomputer is a machine that costs millions and requires its own custom-made room. But Silicon Graphics has just transformed that image with the development of a supercomputer on a chip. The new Power Challenge computers can fit under a scientist's desk, process as much data as 18 supercomputers at 1/10 the price of one of them.
Movie magic now depends on computer magic as never before. Now we expect the impossible. It comes with a price of admission to the world of computer graphics.
The makers of the hit film Terminator 2 used Silicon Graphics computers to create some startling effects. 2 years ago, a $100,000 computer was required to create this creature in the movie The Abyss. Today, Silicon Graphics announced a new computer that can create effects like this for under $10,000. The company says the Iris Indigo is the first computer that puts visual computing in the price range of a PC.
We all the time are trying to top ourselves, and we're trying to give the directors more than they asked for.
For his work on such films as Star Wars, E.T., and Indiana Jones, he's won 6 Academy Awards.
Now there's a new tool, and we're getting directors with new visions that you've never seen before. A lot of that work was in Terminator 2, and there's other shows coming out with the same stuff that could not successfully be done with traditional existing technology.
This, for example, can be done only on a computer. In fact, it was done on these computers at George Lucas Special Effects headquarters, here, where each has been dubbed with a Star Wars nickname, and throughout the industry. Silicon Graphics dominates the field of computer animation.
This, for example, can only be done on computer. Morphing, the smooth transformation of one object into another, is just one of the dramatic new tools made possible by new computer graphics. More quickly than we realize, computers and entertainment are blending into one.
This will touch everyone because TVs now become computers. TVs are going to be things where you interact and maybe make your reservations for plane tickets, make your shopping list, make your email across to friends as well, all interactive. Every one of those will have at the heart of it, another one of these, right? And so this is really the starting point for the hardware part of that solution.
It is hard to imagine the countless uses for visual computing in the future, but not hard to see. Mountains of data and complex problems can be transformed into images that are easy for the mind to grasp. 3D images of Hurricane Andrew, or the hole in the ozone layer over Antarctica, or the undersea world hidden in sonar readings. All of these visions are at hand for those who can ride the wave of data that flows along the information superhighway. The challenges of the planet await us. The technology is in our hands.
No matter what I'm doing now, what they're doing 5 years from now is going to make what I'm doing now look really boring. Things will only get much more fun, much more excited. So I think that's great, and I think that computer graphics is a really important part of the future.
It's one small step for man, one giant leap for mankind.